Dear students, greetings for the day. Today we will study about Central Processing Unit. A central processing unit, also called a central processor or main processor, is the electronic circuitry within a computer that executes instructions that make up a computer program. The central processing unit performs basic arithmetic, logic, controlling, and input-output operations specified by the instructions in the program. The computer industry used the term Central Processing Unit as early as 1955. Traditionally, the term refers to a processor, more specifically to its processing unit and control unit, distinguishing these core elements of a computer from external components such as main memory and input/output circuitry. If a jump instruction was executed, the program counter will be modified to contain the address of the instruction that was jumped to, and program execution continues normally. In more complex central processing unit, multiple instructions can be fetched, decoded, and executed simultaneously. This section describes what is generally referred to as the classic RISC pipeline, which is quite common among the simple central processing unit used in many electronic devices. It largely ignores the important role of central processing unit cache, and therefore the access stage of the pipeline. If a jump instruction was executed, the program counter will be modified to contain the address of the instruction that was jumped to, and program execution continues normally. In more complex central processing unit, multiple instructions can be fetched, decoded, and executed simultaneously. This section describes what is generally referred to as the classic RISC pipeline, which is quite common among the simple central processing unit used in many electronic devices. It largely ignores the important role of central processing unit cache, and therefore the access stage of the pipeline. Hardwired into a central processing unit circuitry is a set of basic operations it can perform, called an instruction set. Such operations may involve, for example, adding or subtracting two numbers, comparing two numbers, or jumping to a different part of a program. Each basic operation is represented by a particular combination of bits, known as the machine language opcode. While executing instructions in a machine language program, the central processing unit decides which operation to perform by decoding the opcode. A complete machine language instruction consists of an opcode and, in many cases, additional bits that specify arguments for the operation. Going up the complexity scale, a machine language program is a collection of machine language instructions that the central processing unit executes. The actual mathematical operation for each instruction is performed by a combinational logic circuit within the central processing unit processor known as the arithmetic logic unit. In general, a central processing unit executes an instruction by fetching it from memory, using its arithmetic logic unit to perform an operation, and then storing the result in memory. Beside the instructions for integer mathematics and logic operations, various other machine instructions exist, such as those for loading data from memory and storing it back, branching operations, and mathematical operations on floating point numbers performed by the central processing unit floating point unit. The control unit is a component of the central processing unit that directs the operation of the processor. It tells the computer's memory, arithmetic and logic unit and input and output devices how to respond to the instructions that have been sent to the processor. It directs the operation of the other units by providing timing and control signals. Most computer resources are managed by the control unit. It directs the flow of data between the central processing unit and the other devices. The control unit directs and controls the activities of the internal and external devices. It interprets the instructions fetched into the computer, determines what data, if any, are needed, where it is stored, where to store the results of the operation, and sends the control signals to the devices involved in the execution of the instructions. Although it does not perform any actual processing on the data, the control unit acts as a central nervous system for the other components of the computer. It manages and coordinates the entire computer system. It obtains instructions from the program stored in main memory, interprets the instructions, and issues signals that cause other units of the system to execute them. The arithmetic logic unit is a digital circuit within the processor that performs integer arithmetic and bitwise logic operations. The arithmetic logic unit is a digital circuit within the processor that performs integer arithmetic and bitwise logic operations. The inputs to the arithmetic logic unit are the data words to be operated on, status information from previous operations, and a code from the control unit indicating which operation to perform. Depending on the instruction being executed, the operands may come from internal central processing unit registers or external memory, or they may be constants generated by the arithmetic logic unit itself. The inputs to the arithmetic logic unit are the data words to be operated on, status information from previous operations, and a code from the control unit indicating which operation to perform. Depending on the instruction being executed, the operands may come from internal central processing unit registers or external memory, or they may be constants generated by the arithmetic logic unit itself. When all input signals have settled and propagated through the arithmetic logic unit circuitry, the result of the performed operation appears at the arithmetic logic unit outputs. The result consists of both a data word, which may be stored in a register or memory, and status information that is typically stored in a special, internal central processing unit register. Most high-end microprocessors, in desktop, laptop, server computers, have a memory management unit, translating logical addresses into physical RAM addresses, providing memory protection and paging abilities, useful for virtual memory. Simpler processors, especially microcontrollers, usually don't include an MMU. The performance or speed of a processor depends on, among many other factors, the clock rate and the instructions per clock, which together are the factors for the instructions per second that the central processing unit can perform. Many reported instructions per second values have represented peak execution rates on artificial instruction sequences with few branches, whereas realistic workloads consist of a mix of instructions and applications, some of which take longer to execute than others. The performance of the memory hierarchy also greatly affects processor performance, an issue barely considered in instructions per second calculations. Processing performance of computers is increased by using multi-core processors, which essentially is plugging two or more individual processors into one integrated circuit. Ideally, a dual-core processor would be nearly twice as powerful as a single-core processor. In practice, the performance gain is far smaller, only about 50%, due to imperfect software algorithms and implementation. Increasing the number of cores in a processor increases the workload that can be handled. This means that the processor can now handle numerous asynchronous events, interrupts, etc., which can take a toll on the central processing unit when overwhelmed. These cores can be thought of as different floors in a processing plant, with each floor handling a different task. Sometimes, these cores will handle the same tasks as cores adjacent to them if a single core is not enough to handle the information. In computing, a processor or processing unit is an electronic circuit which performs operations on some external data source, usually memory or some other data stream. It typically takes the form of microprocessor, which is fabricated on a single metal oxide semiconductor integrated circuit chip. A motherboard, alternatively known as the main board, main circuit board, system board, base board, planar board or logic board, or colloquially, a MOBO, is the main printed circuit board found in general-purpose computers and other expandable systems. It holds and allows communication between many of the crucial electronic components of a system, such as the central processing unit and memory, and provides connectors for other peripherals.